how do you pick the right one to even start with? And then what is your assessment criteria for deciding on one model versus another? The next challenge that I list here is quality data, especially when one of the cool things that large language models did was reduce the requirement for um, uh, organized data, so tabular data or JSON data, something like that. You can just use a report. It can be, written text. So we talk a lot about data quality needs to be great for the model. That is true, but it's the format of the data is less particular than it's ever been before, which is kind of a neat outcome of large language models. On the other hand, it does need to be quality. You can very easily train a new model with bad data and, where it's just false information or not pertinent to the problem at hand, those sorts of things. Um, so how that might shake out for an agile team is a need to start collecting data. Um, it could really slow down your idea for implementing a solution if you find that the data you have isn't quality enough. Number three, difficulties in work estimation. I've hit on that twice now. Training, even once you've selected the type of model you're going to use, training is um, it's not just training a model, it's also developing the right data, especially when we're talking about predictive. Um, we don't know how long it will take with large language models when you're tuning them for your own purposes, meeting your acceptance criteria. It might be impossible. You never know. And you might just stumble on the right solution, you might not. Acceptance criteria is difficult to identify. So there are a lot of different performance metrics you could consider, often not the terms we think in as a software engineering team. And then ethical and compliance issues, that's definitely a challenge. Testing for those edge cases to make sure you meet the compliance requirements of your industry, especially with large language models. Also with data collection and usage is something to consider. So I listed what I think the challenges are. Does the group have any ideas? I probably should have thrown this out at the beginning. I don't see any questions there. As I continue talking, if you think of challenges to your team in integrating AI in your software, drop them in there, and I might be able to address them a little bit later on. I say those are the top five. Yeah, making sure it's useful. That's true with any software, right? Like, hey, we're going to build this thing. Is it actually useful? Who knows? Um, Hopefully you've taken a design thinking approach or something like that so that you have some feedback that what you're building is actually going to be of worth. Okay, here I see. There's two places for question here. Um, Thanks for that, Mark. All right, I'll move on. Next slide here. The consequences of inaction. Um, Volume of data is certainly an issue. So David mentioned quality of data and volume is another consideration. The I touch on this a bit later, but uh, data changes, right? It can require that you modify uh, the whole fundamental model as data changes. If volume is sufficiently high, that introduces a lot of complexity with processing. Uh, I guess the flip side of that is you could have too little volume to be useful. What were you going for there, David? Can you expand a little bit?
Yes, absolutely. Can you hear me?
Yeah,
Yeah. So I was thinking too little. Obviously, some of these models do require larger volumes to be more accurate. So, for the way I think about it, gathering that large amount of volume of data and being able to process it in a way that can be useful to the models is a challenge for us.
yes, yeah. The That's kind of what I hit on earlier about data availability. If you so you may not have been collecting data for long enough, or there might not be enough instances of an occurrence for the data set to be useful. This particularly comes in for me when I'm trying to predict like a failure, a machine failure, or something along those lines. It happens so infrequently that those your data set is imbalanced, right? You have all of these success rows of data and only one failure in many millions of rows. It's very hard to build a model that can understand that well. Good point.
Yep, and that's exactly what I was going for. Something exactly like that. We don't not enough occurrence of something to have a valuable model. Perfect example there. Thank you.
Yeah, the there's not a whole lot you can do. You can bootstrap, so you like reintroduce those entries many times in your data set, which might lend to a lot of false positives. Um, I'm kind of going down a data science track here. Leave it to your data science team to figure out, I guess. Um, Mark through another one here. Yeah. Why use generative AI when you can use a simple solution? That comes down to architecture, right? Like uh, as a software engineering or a technology team, keep it simple, stupid. You can leave off that last S, but in the military, we always had both S's there. Keep it simple, stupid. So don't use a big complex model that you can't understand when a simple one will do, or an if statement might be the solution for your particular use case. And sometimes you don't realize that a simpler solution exists until you've built the complex one and you start to understand, oh, these are the variables that actually impact the predictive value. So we can just base a rule-based system off those few. Um, and that gets back to what I said. It's hard to estimate these things. If you're going to build something, it's very hard to know what patterns might exist in the data, which model is best at detecting that pattern. Um, which approach is the simplest and speediest or best to meet the requirements of your application. We don't know those things until we get in there and play. It's kind of an exploratory process, which is why Agile is great because we can do these tests and test a lot of things, but it's very hard to predict. Uh, all right. Next thing, consequences of inaction. I This is Dolly's attempt to draw an image for me here of AI passing somebody by. So the consequences is you get left in the dust. That guy there, he's just got his hands in his pockets. Reduced competitiveness. So your competitors, alternative software, are going to start using uh, more, we're going to continue using more advanced technology on their platforms. So you need to keep up. I say this a lot when I go into consulting engagements, but I'll say it here as well. Don't use well, I'm also not a marketer, so take this for what it's worth. But don't use a large language model just to use a large language model. There are so many business people out there saying, "Hey, we need AI in our company." No, you don't need AI. You need to meet your business objectives. You need to do that in the most efficient and effective manner. And AI might be a great uh, technology to do that with, but it's not an end in itself, right? it's a means to an end. So while I say yes, reduce competitiveness, focus on the features that you want, not on saying, hey, we have an AI enabled marketing tool, which probably any marketers on this call will say, hey, if you say we have an AI enabled marketing tool, then we're going to get a lot more traffic than if we don't say it's AI enabled or something like that. So that's a different issue. Yeah, technological complexity. The marketers can say what they will. Let's focus on keeping our apps great, simple, as able. Increased operational costs. Number two. So automation is a big part of what I do. I use AI to help automate. An example of that is perhaps tagging call transcripts, something like that. We want to know why people are calling into our call center. Well, I'm going to use a large language model for that, because building an interface for a bunch of people to go through and categorize these things is not the most effective way to get that done. Reduced user engagement. So people will come to expect tools to respond to them in a more common, interactive way. So we have chatbots. We want to ask a question. It used to be you wanted to skip over the IVR system on a phone call and go straight to the person. So you're, matching the 0 button or the pound key, trying to figure out what the sequence is to skip all of the, is this a problem with your checking account kind of things. But now some of these chat tools are like a chat bot on a website is getting to the place where that might actually be a better approach. I'd rather do that than talk to a person that I have some language barrier with, or something along those lines. So that's kind of a one example, but I'll bet this group could come up with other examples of reduced user engagement. I think another one that comes to my mind is people like to be told, what to do with information. For a long time, the web was, especially, I come from the analytics background, so a lot of times we were telling people what happened, and they're like, okay, that's great. Our web sessions went up, but they want to know, okay, what do we do with that information? Are we going to have greater sales from it, or are they just interested in some, blog that was published? So if we can use predictive models or large language models to help people know what to do with the information we're presenting, we're making for a better experience. Poor decision making, similar to what I was just talking about. We're not providing the best information to move forward with. So if you look at a lot of government produced data sets, and it's great that they produce all this data, they upload all these CSV files and sometimes really strange formats that aren't CSV. And they say, oh yeah, make great decisions for your school districts based on all this data that was uploaded. Well, if they could pre-process that data with artificial intelligence tools, or perhaps give me a large language model where I could talk to that data and say, what is the average income for my school district, so that I can plan lunches or whatever it might be. That's so much more powerful, right? So yeah, it helps people make better decisions. And then the last one is difficulty scaling. So I talked about scalable AI solutions. That's an interesting concept. Of course, like processing the data, that's one way to make your AI solution scalable. Another thing to think about is the cost of implementation. If your application is relying on an API connection to OpenAI that's charging you for every request that's coming through, is that actually scalable? Is the return from each user of that great enough um, to to uh, to pay for it, right? Um, that's something that needs to be considered as you implement the AI solution. I'm trying to think of what I must have had a great idea here when I put this down. Difficulty scaling if you're not using AI. I mean, rule-based systems. So a lot of the web used to be a rule-based system, right? Like, and those things became very complex. One of my clients is an insurance adjudication. So they send through, you go to CVS, try and buy some medicine. It gets sent through this system and it gives back a reject or an accept, right? Here's the price for this, um, medicine. That is rule based, and sometimes it has to go through 100 different rules before it gets to the solution on whether or not this is approved and how much the cost should be. Um, that's not scalable. It's very confusing. It's hard to update those. You don't know the downstream effect of an update in the center of it. So we're currently designing tools the um, to predict the downstream effects of any one of those given rules, which is a very interesting thing to do. It, you'd almost say, hey, can we just get rid of those rules and predict the cost and kind of skip over all the in between? But insurers are not keen to do that at this point. That's um, a lot of compliance and business logic to move past. All right. I asked a lot of questions, or I said a lot there. Anyone have any consequences that I didn't listen or list? Uh, Consequences of self-driving cars, that's kind of interesting. I don't know. I think the consequence of not getting to self-driving cars is pretty large as well. Um, I love the idea of just being able to call one up and not even own a vehicle, which is one of the ideas that have been thrown out. Not having enough failure cases. Right. Oh, that's a good point. With failure cases, one thing that we can do is simulate. So we can simulate situations, and they're doing a lot of that with self-driving cars. I think they're making up situations and seeing how the car responds. Um, we did that a lot in the military as well. When you think about, changing a weapon system for the uh, U.S. Army. That's a big change. And then you go to war. What are the effects of that when you're in you know, a land battle versus a sea battle versus, island hopping and all of these things? We have to simulate those because you can't just go out there and blow up a bunch of trucks or weapon systems and say, oh, how did they respond to that? That's a very costly um, thing to do. So you have to simulate in that case. Not getting any experience with AI. Yeah, not recognizing when it's appropriate. This one is uh, something else I talk about a lot with my clients. Have somebody that understands artificial intelligence technology, data science, these types of technologies in when you're thinking about your goals and your maybe changes to your platform, things like that. Whether they're a team member that you give the latitude to go study these things, somebody that you hire in, or if you're a smaller business, bring somebody in to do an assessment or to offer ideas on how to use this technology to move your business forward. Um, I think that's an important one. Thanks, Mark. All right. Practical steps to smart AI integration. So I'm thinking about AI. I'm thinking about agile teams here. I'm thinking about planning your sprint. Um, and just including these tools in new technology. So the first one I list here is consider data use when adopting new processes and/or tools. This gets to the idea of we don't have enough data to build a model around this to be predictive. Or, oh gosh, wouldn't it be nice if we knew how many people had used this feature so we could see if it's worth deprecating or keeping around? Like from the get-go, think about how are you going to measure the usefulness of this process or this new feature. For a web app, I'm always asking my Google Analytics expert, how are we going to tag this? What kinds of questions should we be thinking about with this new feature? Number two, clearly define acceptance criteria. I'll talk a little bit more about this on following slides, but um, as I mentioned, these things are difficult to estimate. It's also difficult to say when it's done. Time box. So, how good can we get the model in the next 2 weeks? That's a great way to approach this. Cross-functional collaboration. So this is like if you're kicking something over to your data science team, your software development team, I think it's very useful to have those groups talking together, or at least appoint somebody from your software development team to really kind of be closely aligned with your data science team, so that you understand uh, acceptance criteria, how long things are going to take, the different interfaces the model might need, how much and what type of data will be required uh, to interact with the model, both to train it and to get predictions from it later on. So the interfaces to the model. Ethical and compliance alignment. These are really, I think probably most of us on this call are technologists. Um, it's not often somewhere we want to spend a lot of time, right? Like it's nice to think about what are the ethical, um, you know, we can form an opinion on what the ethical uh, consequences of these tools are, but it's probably not something we've studied. Like ethics might have been one class in your sophomore year of college, something like that. It's not something you study day to day. And compliance with the law, if you've looked at like GDPR, uh, that's like thousands of pages of legalese, and understanding how to deal with that is difficult. So we need input from the legal team in language that the technical team can easily understand. And here are the rules that we operate within. Uh, we don't collect data that on our customers that we don't tell them about. We make sure the print is readable and not in legalese when we're saying, hey, we're going to use your information for this purpose. Let people have the choice. And I'm getting way ahead of myself here. I have a whole slide on this later. I'll move on. Automate testing against acceptance criteria. I have more on that as well. I always like automated testing. I'm sure there's some strong opinions from people on this call about when it's appropriate and when it's not. But next, acceptance criteria. I think this is a really interesting topic. There at the bottom, I say there's many ways to measure performance. They should be selected in advance to give the data science team clear guidance. But the data science team can also help select those measures. The sorry, I got caught by the comments there. So I list like human evaluation score, perplexity, faithfulness, accuracy, R squared. These are all different ways to measure models and different types of models. You wouldn't expect an engineer or a business analyst or product owner to really understand the intricacies of these measures. They might if they take a keen interest in it, but the data science team should be able to tell you, hey, if you're really interested in how well the model represents the data that we fed it and doesn't hallucinate, then we really need to focus in on faithfulness. That is a key metric that we should set a standard for. My first point there, human evaluation score. So we can use large language models to score large language models, but in my opinion, humans still reign supreme. So, and that's how a lot of these models were trained initially, right? Not initially, but one of the steps in their training was human evaluation. Um, the So what you can do is build validation sets. This is the way the model should answer this type of question, and that's a better set of information for a large language model to test against than just kind of more general solutions where you're saying, did this model answer faithfully? Okay, that's one way. Or you can say, when I ask this question, does the model respond uh, closely to what the human has entered as a valid response? Um, so perplexity is a benchmarking value that you can use. I already talked about faithfulness. That's typically when you're talking about RAG. I use RAG here is a faithfulness. It's five-legged elephants instead of four. Yeah, that's an image situation. The what I'm thinking about a language model in this situation where so say you have a website. One that I just built was for an organization that helps people identify careers. And you build a chatbot for it, and you tell the model, the large language model, hey, source all your responses from the content on this website. So if somebody comes to that chatbot and says, what hours is your office open? And the website says 8 to 5, and the model responds with 9 to 5, well, you know it's just hallucinated and the answer is invalid. So what you're measuring is how faithful is the response of the model to the content that you provided it to answer from. RAG, I say there, is retrieval augmented generation. So you're retrieving some information from a document store, and I got to turn off these comments. I'm getting distracted here. Um, you're you're taking some document store and you're using it to supply for the answer. The and how do you do that? I think it's still pretty early in our development of tools to measure these things in an automated way. But what we have right now is we come up with a list of um, expected values, and you can ask those questions and see, does it respond in the way that we expect? And like I said on number one, you can use a large language to do that, large language model to do that. You can force the model to respond in a specific way. So you could say, hey, when I ask about the hours, respond via JSON with a key value pair, and then you can use your test suite to read that JSON and make sure that the value for hours matches your key. So that would be a way you could set up an automated test against something like that. This is not meant to be a presentation on how to test these things, but these are some ideas you might look at. Accuracy and R squared, these are typical numeric model validity measures. Okay, so when you think about acceptance criteria for a large language model, the acceptance criteria should not be the model, doesn't say bad stuff. It's got to be out of 100 requests, we need 99 of them to not mention anything that would be considered unethical or something like that. You need to be more specific in how you state these acceptance criteria. Next slide here. Testing. So these are comments on testing, not necessarily how. Right. Yeah, don't cuss out your customers. That's exactly the acceptance criteria that I would consider inadequate. Cuss out fewer than 1% of your customers. Some of them deserve it. um, these are comments on testing, not necessarily how to do it. Like I said before, I think it's still a pretty early in the development of technology to test these things well. There's a whole lot of reading that can be done on the subject. The first one, as input data changes, models can drift. Drift is a term we often use in the data science space, and they lose their predictive power. So if you think about a model that predicts height, and then you train it on data, maybe we have height data that goes back 500 years. That is not a good data set to train your model on, because in the past 50 years, the average height of a human has gone up quite a bit because of our changes in food and health. So that's an example over a long period of time of drift. But in the digital world that we now live, things change very quickly. Do people, if you're looking at like testing the colors on your website, is blue in favor right now? That might change, with the season. So, consider that when you're running these tests. And basically, what I'm trying to drive through with this slide is your test criteria needs to exist in such a way that it can pick up on that drift. So you need to provide it new data and ensure that it still meets your quality criteria, whether that's accuracy or something else. So that's where I highlight new relevant data. And then the pieces of software that interact with the model need not change for the model to lose its validity. So we should be running these tests regularly, whether we've touched that piece of code or not. So maybe just do it on a schedule. Sometimes, a lot of test suites run all the tests on a regular basis, something like that. Okay, this last one is about, planning your sprint. If you don't do a good job of testing, or somebody starts playing around with your large language model and gets it to spit out, start cussing out customers or cuss out one customer, and then they post it on Twitter, and next thing you do, you have the product team yelling at you. That can screw up your sprint, right? You're going to be working on fixing that instead of developing new features. So again, test regularly, think broadly about how tests might work, think singularly. Also, the thing I was going to say on this one is also think about when you're deploying something, think about how to protect yourself up front. Like, how might people, this is kind of like a security suggestion, how might people hack this thing and make it do things that we don't want it to? Um, I was reading the terms on, Claude. I was playing with it yesterday and I was reading the terms on it. And it says, if we recognize that you are trying to get our model to do unethical things, you've lost access to it, right? We're not going to let you log in and use it anymore. And I think that's, as we start introducing these things in publicly available products, Maybe somebody's using it as their own chat GPT, so they don't have to pay. They're using your tokens instead of their own. Well, you need to cookie them or do something so that you can turn them off if they're asking things that aren't relevant, or you just respond and say, hey, this question isn't relevant to our product. Look elsewhere for that information. I saw a comment in the chat that I wanted to respond to. How can you see drift starting to occur in models? Yeah, Tom, I think the answer to that is the introduction of new and relevant data to the model. And you just retest the model against the new data set. And if you start to see that the performance declines, then you know that the predictive power of the model has been lost. It no longer responds correctly to the new data. Right. And Stephanie kind of answered similarly there. I think that's right on. Ethics and compliance. I already rambled about this when I brought it up earlier. Large language models will talk about whatever you allow them to. So they're going to give you a response so long as you allow it to. And the part of your user story right up front should be include something about how to protect against what you don't want your large language model talking about. Ethics. The second one is just be upfront with users about how data is collected and what's being used about them. There are so many, I don't know, unethical uses of data across the internet. And it's just kind of a dirty place when you get into some of these products. I see it a lot in marketing to the elderly, where you're saying, "Hey, sign up for this," and then they get 70 calls for Medicare, supplemental Medicare insurance, and we're starting to get some laws that protect from that sort of thing, but there's often not a lot you can do about it. People are being sold things that they don't need, and anyways, I'm getting on a soapbox here. I'm sorry. Be ethical, yeah, right? Like, do unto others as you would want done unto yourself. And that's a great question to ask when you start to build technology. Like, is the way we're going to use this data a way that we would want data used about us? And if there's any question there, then give the user the option to opt out. It used to be that we were going to trick the world into believing that this robotic system was actually a human. And we still see that a lot with these robo dialers. You hear this boop sound, and then a few seconds later, some robotic voice starts asking you questions. Don't trick people. I think you're going to have better success with AI systems, chatbots, dialers, things like that, if you're just up front and saying, hey, this is an automated thing. Here's how to talk to a real person if you're not getting what you need. Automate compliance testing. Test your LLM. Make sure it complies with not giving medical advice. If you're or not giving financial advice or whatever. The last thing there is consider using a platform. I think the compliance is probably the hardest thing to develop yourself. And a lot of these, like if you're using Azure, OpenAI integrations, or there are other tools out there where they have built some of that compliance stuff in. It's just very difficult to keep up with. It's kind of like security. It's one of those things you might offload to a platform rather than trying to develop it yourself. All right. This last slide is just like some easy ways to use AI tools as part of your team. The first one is, you're probably already using this. Track your data. Like points to days is something that we can predict. If your team consistently says, 3 points is this, there are these tasks at 3 points, and then we find that Monte Carlo simulation or something like that tells us that that typically shakes out to be about 4 days. That's an AI example for Scrum team. Um, Many of the tools like Jira or whatever have that built in. LLMs for user stories. This is kind of like a duh one to me. Like if you're not using LLMs to write your user stories, you're probably really good at writing user stories, and that's a big part of your job. But me, when I have to go in and write user stories or requirements, I almost always lean on a LLM to get me started. I always use these as a starting place, but not as the final solution. Make sure you read what the large language model spits out before you copy it and paste it into the task for your team. Acceptance criteria is similar, give you a lot of good ideas, but I harken back to what I said earlier. You know, rely on your experts to think through how best to identify what is acceptable for this feature. LLMs for code, obviously, that's been talked about a lot all over the place. Um, I'm a big fan of Lex Friedman. I listen to his podcasts, and he stated the other day something that I kind of believe, that large language models are better at producing code than people. Like that's already true as a baseline. They're not better at understanding the requirements, but if you use it as a starting place, I think it's a great way to work with code and keep focusing on. He was answering somebody who was very anxious about their job being taken away by a large language model. It's going to be replacing me. I understand that anxiety, and I sometimes feel it myself. And his suggestion was to focus on really being able to translate business requirements to code, and be the master of the large language model and the code that it produces. LLMs for documentation, another easy one. These are all like, hey, LLMs produce language. Use them to produce language. That's kind of sum that up. When you use these things, user stories, acceptance criteria, any of it, build a template to teach like in ChatGPT, you can build your own GPT, right? So you give it, 100 user stories that have previously been written, and then you tell it, hey, I want you to produce user stories that are similar to what I've done in the past, um, and it will be in your style more than if you hadn't given it that context up front. Same for code or whatever else. A lot of, the easy way, or the way I see that being done a lot right now, is training GPTs to write social posts and things like that for you. So give it a bunch of your history of your Twitter posts, and it can kind of match your style. They're dumb though. Oftentimes they'll repeat the exact post that you've done previously. All right, that's it. I hope you enjoyed it. I hope it was useful. I hope you learned something. Hit me with questions.
Hey, we've got some questions on Slido. We paste this in here. And here, I'll tell you what, let me bring it up and I'll just read through them in order. Okay, so top one is, how can you help your team avoid over-engineering solutions when the devs and architects are really wanting to use the newest cool technology?
I would love to know the answer to that. I think, that's a lifelong battle, right? Like leading an engineering team, that was one of the most difficult things for me. Was team, let's keep it simple, let's build the feature, but then they're talking about, oh, we're going to have technical debt if we don't think it through well, or we don't use this newest technology, or we need to learn about this newest technology. How do you balance that? One approach that I've seen organizations use is to give people once a quarter or something, give them a week to play around with new tech and really understand how it's useful for their organization. That's all I've got on that. That's a difficult question. I will say something else. I listened to a guy speak this morning. He's built 40 different startups, and he builds them all by himself. And he makes, I think he said one of them is making $100,000 a week right now. He built it using CSS, HTML, PHP, and jQuery. And these are, well-used apps out in the world. So we do not need, you know, the newest flavor of React or whatever for every new project.
Okay, I hear about teachers using it to grade, I guess, using LLMs to grade papers and students using it to write papers. How do you think education will be impacted by AI?
I think we still have to teach our children the basics, how to read and write. You can't even interact with a large language model if you don't know how to read and write. Although that might change with Neuralink. the the new thought, like models can hallucinate, they can make things up, and they can draw inferences from wide, uh, like unattached ideas. But I think we still have the upper hand on being creative, like coming up with new ideas. So, and I don't know if that's right. Somebody could probably make a case that isn't really the case. I think we're going to learn to become good at working with them, and we're going to find new uses for our brains, uh, as we have always done. There are a lot of books, like the Technology Trap is one example where people think through what is the impact of new technology, and it's often scary for a large part of the population, right? When the loom was invented, there were groups in England going around and burning them down because it was taking their jobs. They didn't have any usefulness anymore. And we all want to be useful to those around us. I think this is one of the most important questions of our age. I don't know the answer, but I I do want to help solve it.
Okay, can the Six Sigma concept of design of experiments be applied to simplify AI models? Particularly useful when there are too many variables or too many potential independent variables.
Yeah, so I didn't know that Six Sigma had anything to do with design of experiments, but that was a college course that I took in my master's program where you're designing statistical experiments to test the validity of hypothesis. Like, um, if I apply fertilizer, does the corn grow taller? So yeah, that's a very easy way to uh, ascertain whether or not a treatment is effective. There are other ways we can do it now with large language models, or not large language models, with machine learning models, where um, there's a concept called uh, shoot. There's a book. I have a book laying around here somewhere. I'm gonna move on from that. Explainability. That's it. So if we well, being able to understand what are the variables that are driving the decisions in this model, so we don't have to go through and test one or two variables at a time. We can kind of look across the model and figure those out. There are ways to do it. Short answer.
Google recently said that 25% of their code is being generated with AI. Can you provide any context around that? Is this just like code completion or more detailed actually writing code?
I would assume it's both. I don't know what Google is referencing there. I would assume that kind of across the industry, it's probably higher than that now. I know that when I go to write code, I typically start with ChatGPT. I need code that does this. I use that as my starting place, and then I modify it to get it to do what I want. So I would say my personal code is probably more like 90% AI generated.
Cool. What testing strategies would you recommend for testing AI?
Uh, other than what I already talked about, I don't think I can say much else on the subject. I mean, there are specific ways to test models, and I think your data science team should be well trained on those. Uh, you can run, your test suite. Uh, you can include those kinds of tests there, but I'm not really a testing expert, so I probably should stop with that.
So I had a question for you on the idea of using LLMs to generate user stories. In my experience, getting the user story right and refined down small enough tends to be like sometimes 90% of the effort that goes into developing is figuring out what to leave out and exactly what to be and what's not. My concern of using an LLM to generate that is I won't have to make all those decisions, and we may end up with scope creep that when like how do you see that? But I'm also thinking of stories that like can be completed in 2 to 4 days, with a few developers. So maybe what would you say kind of with that kind of thought of it? Because that's why I don't see it as being super useful, but it may just be my particular use case.
Yeah, I think you're probably really good at it, would be my thought on it. So you might not get a whole ton of value from using a large language model to help you. Um, for the particular issue you described, you might copy the user story that you wrote, paste it in there, and say, how could I break this into multiple user stories or something like that, and get some guidance there. But yeah, you got to figure out how these tools work for you.
Okay, yeah, that makes sense. Cool. Well, did anyone else have any other questions? Probably got time for one more here. Is that in the chat? Okay. Okay, well, Mark, thank you so much for coming. It was very useful. I enjoyed it. I learned a lot. Hopefully everybody else did too. But thanks for taking the time. I really appreciate it. This was very, very insightful, and it makes me realize how little I know about this particular field and how I probably should spend more time in it. So thank you. Thank you so much. Thank you, everybody, for coming. We're going to be talking about DevOps next week, coming from a red trailer, probably somewhere in Virginia. So we'll see you next week talking about what is DevOps. And thank you, everybody, for coming. Have a great rest of your week.
Thank you.